Imagine a world where the very ground beneath your feet is not solid, but a restless, shifting giant that breathes through the ages. For billions of years, our planet has pulsed between states of fire and ice, a delicate dance dictated by the cold mechanics of the cosmos. We often think of the Ice Age as a distant, frozen memory, a prehistoric backdrop for mammoths and early humans struggling against the bitter wind. But what if the story is more complex, and we are actually living in the middle of a chapter that has not yet ended? To understand our future, we must first look back at the terrifying scale of the snowball Earth, when the entire globe became a frozen marble. Around 650 million years ago, a runaway cooling effect gripped the planet, sending glaciers marching from the poles all the way to the equator. This was not just a cold winter, it was a planetary catastrophe, where the oceans froze over a kilometer deep, choking the life within. Temperatures plummeted to -50°C at the equator, turning our vibrant blue home into a silent, white wasteland for millions of years. Scientists like Joe Kirschvink, who coined the term Snowball Earth, suggest that only a few resilient organisms survived near volcanic vents. This extreme state reminds us that Earth's climate is a fragile equilibrium, easily tipped by the slightest shift in its orbital path or atmosphere. While we fear the heat today, the shadow of the glacial period still looms over our history like a sleeping predator waiting to wake. Strictly speaking, we are currently residing in a glacial age, specifically a brief, warm window known as an interglacial period within the Quaternary. Since the Earth formed, there have been at least 5 major glacial ages, each lasting tens of millions of years and reshaping the map. The rhythm of these cycles is governed by the Milankovitch cycles, a series of gravitational tugs from our celestial neighbors that tilt our world. These cycles change the shape of Earth's orbit and the angle of its axis, determining exactly how much sunlight kisses our northern hemisphere. When the tilt is just right and the orbit stretches, the snow of winter fails to melt in the summer, beginning a slow crawl. Over thousands of years, this unmelted snow piles up, compressing into massive ice sheets that reflect even more sunlight back into the void. This creates a feedback loop, a cold engine that grinds forward until half the continents are buried under miles of solid, unyielding blue ice. We emerged from the last great frozen expansion only 10,000 years ago, a mere blink in the vastness of geological time. As we stand in this warm sunlight, some researchers are asking a chilling question. Is a mini ice age already approaching our doorstep? The idea of a mini ice age sounds like science fiction, but history tells us that the Sun is a temperamental star. Between 1645 and 1715, the Earth experienced the Maunder minimum, a period where sunspots nearly vanished from the solar surface. This dip in solar activity coincided with the Little Ice Age, a chilling era where winters in Europe and North America turned brutal. Paintings from that time show the River Thames in London frozen solid, with frost fares held on ice thick enough to support horses. In New York, people could reportedly walk across the frozen harbor from Manhattan to Staten Island, a feat impossible in our modern world. Crops failed, famines spread, and the social fabric of civilizations strained under the weight of an unexpectedly cooling planet. Fast forward to 2015, when Professor Valentina Zarkova presented a startling mathematical model at the Royal Astronomical Society. Her research suggests that solar activity is governed by 2 internal magnetic waves that occasionally cancel each other out. According to this model, these waves are falling out of sync, leading to a potential 60% drop in solar activity by the 2030s. If her predictions hold true, we could see a repeat of the Maunder minimum within our lifetimes, triggering a new mini cooling event. But wait, how does this fit into the global headlines we see every day about record-breaking heat and melting poles? This is where the story gets complicated, as we are currently caught between 2 opposing forces of planetary change. On one hand, the long-term orbital mechanics of the Milankovitch cycles suggest we should be cooling down over the next few millennia. On the other hand, the massive injection of greenhouse gases into the atmosphere is acting like a heavy thermal blanket. Since 1950, global temperatures have shown a clear upward trend, rising 10 times faster than any natural warming event in our history. Even during the coldest winters, the overall energy trapped in our oceans and atmosphere continues to climb to dangerous levels. So, could a drop in solar activity actually save us from global warming, acting as a natural cosmic break? Most climate scientists, including those at NASA, argue that even a deep solar minimum would barely dent the current warming trend. The cooling from a mini ice age might only lower global temperatures by about 0.3 degrees Celsius, hardly enough to stop the fever. To understand what a real ice age looks like, we have to imagine a world where the thermostat is broken entirely. To visualize the true power of a glacial period, we must look at the peak of the last one, about 20,000 years ago. During this time, a massive wall of ice known as the Laurentide ice sheet smothered almost all of Canada and the northern United States. This was not a thin dusting of snow, but a colossal slab of solid ice, nearly 4 kilometers thick, heavy enough to warp the crust. Under its immense weight, the Earth's surface actually sank, and the global sea level dropped by a staggering 120 meters. As the water was locked away in glaciers, the English Channel vanished, and a vast grassy plain called Doggerland connected Britain to Europe. On the other side of the world, a land bridge emerged across the Bering Strait, allowing life to wander between Siberia and Alaska. But this expansion of land came at a terrifying price, as the lush forests of the north were replaced by a harsh polar desert. The wind would have been a constant, howling enemy, carrying clouds of fine glacial dust called loess across a landscape of permafrost. Even the tropics were not spared. While they remained ice-free, they became significantly drier, causing rainforests to shrink into small, isolated pockets. If such a world returned today, our global civilization built entirely during the stable warmth of the last 10,000 years would collapse. Our most iconic cities, from Chicago to Stockholm, would be slowly ground into dust by the relentless advance of moving mountain ranges of ice. Agriculture would become impossible in the Northern Hemisphere, forcing billions of people to migrate toward a narrow band of habitable land near the equator. This leads us to a profound realization. The stability we take for granted is actually a rare fluke in the long, chaotic history of Earth. For most of the last million years, the Earth has been a cold, dry, and dusty place where survival was a daily struggle for our ancestors. We are the children of the interglacial, a brief summer in a year that usually lasts for 80,000 years of winter. Some theorists, like those studying the Clathrate gun hypothesis, worry that sudden shifts in temperature could trigger even more extreme feedback loops. If the Earth warms too much, it could melt the permafrost, releasing vast amounts of methane that accelerate warming to a tipping point. Paradoxically, some models suggest that melting Arctic ice could shut down the Gulf Stream, plunging Western Europe into a localized deep freeze. This day-after-tomorrow scenario highlights how delicate the conveyor belt of ocean currents is in maintaining our current comfortable climate. The mystery of the Ice Age is not just about the cold of the past, but the precarious balance of the world we inhabit right now. If a mini Ice Age were to arrive by 2030, our high-tech world would face a test unlike any in recorded history. While the global temperature might only drop slightly, the shift in weather patterns would be chaotic and unpredictable for farmers. We could see years without a summer where late frosts destroy wheat and corn across the breadbaskets of the world. Energy grids would groan under the weight of record-breaking winters as cities scramble to keep the heat flowing to millions. But even this chilling prospect is overshadowed by the much larger, slower cycles that have governed Earth for eons. Deep in the ice cores of Antarctica, scientists have found a rhythmic record of Earth's breath stretching back 800,000 years. Each layer of ice traps tiny bubbles of ancient air, acting as a time capsule for the atmosphere of the distant past. These cores show that CO, two levels and temperatures have moved in lockstep, dancing together through every glacial and interglacial period. Yet, for the first time in millions of years, the CO2 levels have spiked far beyond the natural limits of the cycle. We have essentially pushed the Earth off its natural track, entering a no-man's land of climatic uncertainty that defies historical comparison. This leads to a fascinating paradox. Human activity may have accidentally delayed the next major glacial period for 50,000 years. By burning fossil fuels, we have created a greenhouse shield that might be strong enough to keep the ice sheets at bay. But this shield comes with its own price, as rising seas and extreme heat threaten the very stability we sought to preserve. It is as if we are trying to stabilize a wobbling table by piling weights on one side, only to risk the whole thing collapsing. Some scientists propose that we are entering a new epoch called the Anthropocene, where humans are the primary drivers of Earth's climate. We are no longer just passengers on this rocky ship. We have taken the wheel, but we don't quite know how the steering works. If the sun does dim in the 2030s, it might provide a temporary reprieve, a brief cool breeze in an otherwise warming world. But we cannot rely on the sun's temperamental nature to solve a problem that we have created with our own hands. The history of the ice ages teaches us that the planet is capable of massive, sudden shifts that ignore human borders. Whether the future is one of rising fire or encroaching frost, the lesson remains the same. Balance is everything. As we look toward the 2030s, we are forced to confront the dual nature of our planet, both a nurturing garden and a chaotic engine. Whether the sun dims or the carbon continues to trap the heat, we are moving into a climate that humanity has never seen. The deep history of the Ice Age reminds us that our modern civilization is built on a foundation of temporary geological luck. We are like travelers who have enjoyed a long, sunny afternoon, unaware that the seasons of the Earth are far longer than our lives. If the glaciers were to march again, they would not care about our politics, our economies, or the borders we have drawn. But perhaps the most important lesson from the snowball Earth and the Maunder Minimum is the sheer resilience of life itself. Life has survived the freezing of the entire ocean and the scorching heat of the dinosaur eras, always finding a way to persist. The question is not whether the Earth will survive the next shift, but whether the world we have built can adapt to it. Understanding the Milankovitch cycles and solar waves gives us a glimpse into the gears of the universe, but knowledge is only the first step. We are now at a point where our collective choices will determine if we remain in this comfortable interglacial summer or push into the unknown. The Earth does not owe us stability. It is a dynamic system that has been changing for 4 billion years and will continue long after us. We must learn to respect the immense scales of time and energy that govern the ice and the fire of our world. Perhaps a mini ice age in 2030 would be the wake-up call we need, a reminder of how small we are against the cosmic clock. Or perhaps it will be just another ripple in the vast ocean of time, a minor footnote in the long biography of our planet. As you look up at the stars tonight, remember that the light reaching you is the same energy that fuels the cycles of our home. We are part of a grand, celestial mechanism, and every breath we take is supported by the delicate balance of 1,000 variables. The ice is not just our past, it is a mirror reflecting our vulnerability and our incredible potential to understand the universe. We may not be able to stop the sun from dimming or the axis from tilting, but we can choose how we protect our shared future. So, what will the Earth look like in 10, 100, or 1,000 years? The answer is partly written in the stars and partly in our hands. For now, the sun is still shining, the ice is still distant, and the story of our world is still being written by us.